Hi, my name is Walker Daniel, and I'll be presenting my Lab 2 Charge Tapes Revisited. Introduction. The purpose of this lab is to compare the results of Lab 1 to the new computational model of a charged tapes treated as charged rods. And a little preview findings. Based on the data, the tape is positively charged with a charge of 9.33 E negative 8, and it lost about 5.833 E plus 11 electrons. And this is from Lab 1. Some fundamental ideas. The gravitational force, the force of gravity is mass multiplied by the gravitational constant 9.8. Newton's third law, the object is at equilibrium and it applies an equal and opposite force. And here's a very helpful electrical force equation. There are some key assumptions we have. Both tapes have equal charge. There's no outside forces other than electrical force and gravity, and the tape charge acts as a rod of charge, equally distributed. This is our experiment for lab one that we used in conjunction with lab two. The system was suspended. The suspended tape and the surroundings was the earth and the lower tape. First, we charged the strips by putting them on the table. We all remember that. Bring strips of charged tape to different objects and note observations. Then we take two charged tapes and suspend one above the other so that there's a small dip. Then we move the lower tape until the upper tape begins to move upward. And then finally, we just note the distance that it took between they started moving. And then we did, here are the measurements. Pretty standard. Tape mass was 0.002 kilograms, length 0.2 meters, surface area 0.04, distance between tapes 0.2 meters, gravity and electrical force were both equal to each other or equal but opposite signs. Observations, the two charged tapes repelled, charged tape and hand attracted, charged tape and discharged pen attracted. Based on these observations, we can see that the tape is positively charged because it attracted to now the no negatively charged pen. And then this is kind of what the model looked like if it was a evenly distributed strip for the suspended tape. And here's my code. As you can see, here are all our constants. The math was right here, pretty standard stuff. And then the visuals were right here that made the arrows. And this is kind of what it looked like. As you can see, this is the lower tape, this is the upper tape. Yep. And some possible errors. There were some routing errors, maybe some outside forces, tape lost charge too quickly, and calculation errors. And finally, future questions. The first one is, what if the was a point charge like in lab one? Well, as you can see here, point charge was 9.33 e to the negative, and line charge was 1.962. So we can see that the point charge is much smaller than the line charge. And then why are the data different? The data is different because for the line charge, we calculate the data for each little point, whereas which is much more accurate to real life. That's it. Thank you.